Welcome back, ladies and gentlemen, to part 12 of our Unity Beginners tutorial series. I'm glad to have you with me today, as today is a special day, for our little Waluigi here is going to be introduced to some new friends to play with. Or should I say enemies? Frenemies? Anyway, before we get into it, I would like to thank you all very much for taking the time to come visit and support the channel. It's been very encouraging to see how very close we are to our only goal of 100 subs, and it's been excellent seeing all your progress and hearing back from you all. Right, let's get prepared by downloading our enemy sprite sheet from the link in the description below, and let's get cracking. Once you've opened up your project, go ahead and add your sprite sheet into the sprites folder, and let's prepare our sprites ready to be put in our game. So just like last time, our sprite mode will be multiple, and our pixels per unit will be 64, as all our sprites are 64 by 64. Don't forget to hit apply, and let's go into our sprite editor. And once your sprite editor has opened up, exactly like last time, we're going to hit slice, change type to grid by cell size, pixel size 64 by 64 of course, hit slice, and there we go. All sprites are now separate. You can go ahead and name these whatever you like. I'm going to keep it simple. I'm going to call this one Orange A1. I'm going to copy that, paste it into the second one, simply call that Orange A2. And of course, here it's going to be Red A1. Copy that, and this will be Red A2. There we go. And when you're ready, hit apply, and let's get them in. Now before we go throwing our enemies into our project, let's first discuss how our enemies are going to work, and for that we're going to refer to the iconic Goombas and Koopa Troopers from the Super Mario Bros. Series. Green Koopa Troopers walk and patrol along the ground without a care in the world for pitfalls and obstacles, and will turn around and walk the opposite way when hitting a dead end. Same goes for the Goombas also. And they'll also interact and bounce off each other, turning each other around. The red Koopa Troopers, on the other hand, are often seen patrolling on heights or floating platforms, and are very mindful of ledges and will turn around when they run out of ground to walk on. It are these behaviours that we're going to replicate in our project. As for how, well, let's go to the drawing board, shall we? First, I want to cast our minds back to when we created our player game object and how we added a ground checker at the base of the feet, which would determine whether or not we were grounded, which ultimately controlled when we can and can't jump. We're going to do something very similar with our enemies using what are called Raycasts. Now what is a Raycast exactly? A raycast is an invisible beam that we can compare to, say, a laser pointer that we can project from a point in a specific direction that can detect any colliders within its path, and when it does, we can decide what happens. For example, here is how our grounded patrolling enemies are going to work. We're going to create a contact checker, which will be our beam, our raycast. We're going to shoot that raycast to the left, which will be the direction that our enemies will move by default. We're going to give it a fixed length because rays are infinite by default. While our ray has not detected any collisions, our enemy is going to continue moving to the left and our contact check will be false. However, the second our contact check breaches and hits another collider, it will ring true, and what will happen is that will turn our sprite, flip it 180 degrees, so it will move to the right, and of course our raycast will also be then pointing to the right, until it hits another collider and it will return moving back to the left. Now what about our platform patrolling enemies? How are they going to work? We're going to use the exact same method, except we're going to shoot the ray down, and it's going to pick up whether or not we're hitting a platform beneath our feet. If we are, so we're just going to change the triggers around, if our contact check is true, then it registers we're on ground, we're on a platform, we're going to move and keep moving to the left until the point in which our contact checker, our raycast, does not detect any collisions. Therefore, it will check as false, telling our little enemy here that, uh-oh, you've run out of ground, you're going to fall to your death. To which it will flip 180, move to the right, uh-oh, run out of more ground over here, and turn around and go back to the left. Sounds pretty straightforward, right? Well, now we know that, let's get our sprites ready for coding. Now we're back in our editor. Let's go ahead and open up our enemy sprite sheet, and you can choose orange or the red. It's entirely up to you. I'm going to use the orange and drag it into our hierarchy. If you can't see him because he's behind your platforms, just raise him up so you can see him, just like so. I'm going to double click on him so we can get a closer look. And we're going to add two things. We're going to want a collider, of course, because we want to be able to collide with our player. And we're going to add a rigid body because we want it to experience physics such as gravity. So go ahead and add those two components. I'll add a box collider 2D and I'll add a rigid body 2D as well. And while we're here, let's tidy up and edit our collider. I'm going to drag this so it fits him nice and snug, just like so. And there we go. So now that he's ready, let's go and add and write a script to him. So in our scripts folder, right click, and let's create a new C# script, and we'll call it ground patrol. And there we go. Once it's ready, double click to open it up. So what do we need our enemy to do? Well, we need it to move first of all. So go ahead at the top here, type in our first variable, and we'll call it public float. Let's say move speed, just like so. And we're also going to want a value that will be the length of our raycast. So underneath public float, call it ray length, just like so. We're also going to want a private bool that is going to tell us if we're moving left or not. So type in private bool, call it move left. And one last thing, we're going to want a public transform where we're going to place our point from which our raycast is going to be shot from. So type public transform, and we can call this one contact checker. There we go. Now we've punched in our variables. Let's go to our start function, and when we start the game, our enemies are going to move to the left. Therefore, we're going to say that our move left bool equals true. And how are they going to move? We're going to do that in the update here, and we're simply going to say transform.translate. Okay, and in the brackets, we're going to pick a direction, a vector. So as we're in 2D, we'll do vector 2. And we can pick either left or right, up or down here. And of course, we want to use left. So vector 2 dot left. That'll be our direction. How fast are we going? We're going to multiply that by our move speed. There we are. Which is going to be multiplied by time dot delta time. There we go. That's our movement done. Now, let's get to writing our raycast. We can do this in the update function also, but as raycasts are a physics element, I'd like for us to create a void fixed update. There we go. And we're going to first give the name of the point in which our ray hits. So go ahead and type raycast hit 2D. And let's give that point a name. So the point in which our raycast hits a collider will be called contact check, just like in our diagram. And now what is our raycast, our beam? So let's go ahead and fire that by typing in physics 2D dot raycast. Now we have to give our raycast a few variables as we've discussed. It needs a point of origin, where we're going to shoot it from, the direction it's going to be shot, and the length of our beam, the length of our ray. So first of all, we know we're going to have our origin be our contact checker up here. So go ahead and type in contact checker dot position. There we go. The direction, of course, is going to be to the left. So we can go ahead and type in another vector2 dot left. And of course, the length will be our ray length, just like so. Now that we have the raycast set up, let's now have it relay information back to our enemy, because he's going to be asking himself some questions and he needs some answers. The first question is going to be, if contact check is equal to true, with double equal symbols there, so if I've hit something, what am I going to do? Well, he's first going to ask, well, am I moving left? So if move left is equal, once again, to true, then I must turn around. If I'm moving left and I've hit something, I must turn myself 180. So go ahead and type in transform.Euler angles, because we're going to flip it on an axis here. And that value is going to be equal to new vector2. And of course, we want to flip it on the y-axis, because it's going to go 180 degrees the other way. If we did it on the x, he'd be upside down. So the x value will be 0, the y value minus 180. Therefore, if I'm moving now to the right, then I'm no longer moving left. So move left equals false, just like that. But now our little guy has realized, well, if I've hit something and I'm not moving to the left, I must be moving to the right. Therefore, I must turn around to go back to the left again. So to say that, we're going to type in else, which is another way of saying otherwise. Open up some curly brackets. I'm going to flip him back around. So transform.Euler angles equals new vector2. And we're going to put both values as 0 to bring him back facing the left. There we are. And of course, if he's facing the left, he's moving left. He's realized, aha, okay, I now move left. So it equals true. There we go. Give that a save, guys, and let's go back into the editor and put this to the test. Once everything has compiled, go ahead, add the ground patrol script to our enemy, and while we're here, right click to create an empty game object, because we need to create the origin from which we're going to fire our ray from, which of course is our contact checker. So go ahead, name that contact checker, just like so. And in the corner here, in the inspector, let's give it a gizmo so we can see it. And we don't want it to be shooting from within, we want it to be a little bit in front of him, like that. Like he's shooting it from just in front of his eye there, like a laser, like Superman. Then, let's go into our inspector. Let's add our contact checker transform, just like so. Let's give our ray a length of 0.1 and a move speed of our enemy of something steady like 3. Then, before we test, let's put him somewhere where we can get a good look at him, shall we? Let's put him over here at a harm's way from our player. Go ahead, hit play, and we should see now he's moving to the left, he hits something, he moves to the right, and changes direction once again. Excellent, this is looking good. Okay, let's go back into Unity, and let's look at repeating this, but with our other enemy, our platform patroller. So go ahead into your sprites, let's find our other little fella, put him into the scene, make sure you can see him clearly. Let's zoom in, handsome little fella. And of course, we want to add a box collider 2D and another rigid body 2D. And don't forget, edit your collider, get him looking trim. That will do, looking good, looking good. And when you're ready, go ahead into scripts, create new C# script. I'm gonna call this one platform patrol. And when you're ready, go ahead and open it up. Now, of course, we're not going to write all that code out again. We are just going to copy it from our ground patrol and make a few changes. So go ahead, copy all that we need from ground patrol, just like so. Then we're going to go ahead and paste it in there. Excellent. So all we need to change is the direction of our raycast, which is here. So instead of vector2.left, we're going to do vector2.down, and we're going to change this statement here to false, because we want him to act when he realizes, uh-oh, I'm not touching ground, I'm going to fall. Save that now. Let's go back in. And once again, when you're ready, go ahead and add the script to our new enemy. Of course, we need a contact checker. So go ahead, create another one of those, contact checker. Give it a gizmo so we can see it. I'm going to go orange and place it just a little bit ahead of him, just like that. So the beam is going to shoot down from here. So it's going to detect when there's no ground a little before he gets to the edge, just to be on the safe side. Go into the inspector, make the necessary updates, drag your checker into there. Let's give the length this time of 1. I don't think we need it so small. And a speed of 3. Then when we go ahead and hit play, both our enemies should be having a good old time patrolling their spot. There we are. He's not falling from there, and he's not going anywhere because he's very lost, he's very confused. Happy days. All right, let's go back into the editor, guys, and go and take a well-deserved coffee break, as that's the end of today's video. We're not done with our enemies, however. There is a fair few more things we have to take care of, but we will address that in the next video. As always, thank you very much for joining me, guys. I'm glad you're enjoying working on your projects at home, wherever you are in the world. And if you need any help, do not forget, in the description below are links where you can download copies of the code in this video today. We're so very close to that landmark 100 subscribers. Thank you all very much for your continued support. And if you see the value in these tutorials and they have helped you in any way at all, please spread the good word and do consider subscribing, for there are more tutorials on the way. Take care, guys. All the best, and I'll see you soon.